What's going on, ladies and gentlemen? Thank you so much for tuning in. In today's Mikey Pipes HVAC training video, we are going to have a triple header for you. We are going to wire a Taco SR503 or 4. I think it's a 3 or 4 zone switching relay for circulators. We're going to wire that to a boiler, and this boiler is going to be the US Boiler Burnham Alta. Then we are going to run into some problems. So make sure you stick around. We're going to be troubleshooting a control board or the boiler. I don't know what it's going to be yet. Well, actually I do, but you guys don't know what it's going to be yet. So make sure you stick around. If you run into troubleshooting a switching relay not turning on a boiler, or boiler not turning on because it's not getting a signal to turn on, this is a video you're going to want to watch. It's one you want to share with your coworkers and colleagues. Share it with your entire team. And if you live in the Long Island, New York City metropolitan area and you want some hands-on training, open enrollment will be announced in the description box down below when it's available. So it is now the end of March. We're the 24th of March, 2025. Stick around. You're not going to want to miss this. Right now, we are finishing up installing the thermostat wall plate to the wall. And this wall is just a 2x4 piece of 2x4 that is going to duplicate a wall in a home, residential setting, or an office setting. We're going to wire that thermostat to the control for one of the zones. We're going to wire the switching relay to the boiler, and we're going to pray with our fingers crossed that everything works. So stick around, guys. All right, ladies and gentlemen, we're going to start with this, a traditional battery-operated single-stage cooling and heating thermostat. Nothing fancy, not touchscreen, not Wi-Fi, just a digital display that runs on batteries. We have multiple terminals in the back of the thermostat, RC and RH, for your relay for heating, relay for cooling. There's your 24 volts. G for fan, Y for cooling. There's no Y2, even though you could have that on an upgraded model because there's no terminal there, no pin on the terminal. C is common, O and B is your reversing valve, W is your heating circuit, W2 also not there, would be an upgraded model of this. Standard thermostat, nothing crazy, right? We have the mounting bracket or the wall bracket on the wall. All of our terminals equal up there as well. We have 5 conductor wire ran to the thermostat, and in the boiler room we have our SR504 4-zone switching relay. Everything's wired here for line voltage. We have 110 volts coming in on the hot side of this terminal, neutral, and then we have 2 zones there. On the top is our low voltage connections. Isolated end switch is just a dry contact switch. When these two are, when this is energy on, this is told to close, the circuit closes, and you'll see they'll turn on the boiler. Zone 1's already wired with R and W, the little tampon string hanging out there. Just keeping it real. So we're gonna wire in zone 2 from the thermostat here. Most of the wiring is already stripped there. Now, when you cut away the wire, the insulation around the conductors, you wanna make sure you don't nick any of the wiring on any of the conductors, any of the insulation on the conductors, kind of like I did with that one right there. See, it's a little nick. So when it's a little nick like that, see that right there? You want to pull back the string, and then you'll cut away that because you don't want to have any shorts there. This wire, don't worry about that for right now. We'll talk about that in a minute. That's going to our boiler. But let's wire in for cooling only. There's only 2 wires we're going to need. And you know what 2 wires are going to be?
Yellow and common.
Wrong. We're going to use, well, yellow would be, if you're going to use industry standard, would be Y, and common would normally be blue. Okay? But since we're cooling only, industry standard is that we're going to use the red wire for RH and the white wire for W. Okay? The other 3 wires are not going to be used here. That is the standard. Now, it could be any standard that you want to use in your head, but the industry standard is R is always the red wire, W is always the white wire. Okay? But if you're going to use anything you want, you can use anything you want, but you shouldn't, right? Because you should stay within protocol and within standards. But if whatever you use here, you need to use at the boiler or the zone relay. Okay? So let's use R and W. R is going to go on RH,
Okay.
and W is going to go on W.
Said R and W.
Well, we have the red wire and the white wire. Wrong. Does not go in there.
Okay. Sorry.
And then give it a little tug. Make sure it's nice and tight. Good.
Okay.
Now do the white wire. All right, so we have a red wire, which is on RH. Now, this was a much more simpler thermostat. You're just gonna have two terminals. You're gonna have R and W,
Okay.
right? Standard heating only thermostat, like a little yo-yo, TF87, Honeywell, for example.
Okay.
So when the thermostat is calling, the circuit between RH and W is closed. There's no power there, but the circuit is closed, okay? Now, well, actually there's power, whatever, I'm not gonna confuse anyone, but our batteries are in a thermostat. We're gonna put that on the wall there. Watch. Well, you have wires in the way.
Okay. Sorry, I didn't know how to show this.
Okay, so now, right now, for example, hope you guys can see the screen. We are set for heat. We are reading 64 in ambient temperature in the room, and it's set for 61. Now, on our opposite end of the thermostat wire between R and W, right, would this circuit be open or closed right now?
Right now with the heat on, I thought you just told me it would close the circuit. It would link the two
Okay,
wires together.
wrong answer. A good technician is observant of his surroundings, okay? The set point is 61, it's reading 64. So the circuit is
Open, off.
correct. Now, I want you to strip away a little bit of the insulation on the red and the W wire,
Okay.
and then we're going to test for continuity on R and W, or R, H, and W, the red and the white wire. All right, let's set that for continuity. Great. And it is also a very good habit to touch the two leads together to make sure that we are reading continuity. Perfect. We hear that little beep. Now, R and W, touch those two wires together with your two leads. Touch the two wires with the two leads. We have no continuity. We're going to raise up the temperature. Heard that little click. And the second you heard that click, you have continuity on those two wires. Perfect. Now, these two wires here, right, need to go on the two terminals on our switching relay. Remember, we're not using any of the other two wires
Okay.
for this thing, so we can cut away those extra wires. And then the red wire is going to go on zone 2 for R, and the white wire is going to go on zone 2 W. All right, so we have our red and our white wire hooked up to zone 2. Everything else here is connected with the exception of this wire here. Let's turn on power. And right now you see we have our green light for power is illuminated. We have zone 1, a red light on that illuminated. Zone 2, a red light is illuminated. Let's see what happens when we lower that thermostat. Wait for that click. I didn't even hear the click. Did you hear the click?
Yeah, I did.
I did, okay. Zone 2 is off. The only zone on right now is zone 1, which is going to another system. So for training purposes, let's just disconnect the red wire from
which zone?
actually disconnect the white wire from zone 1.
From zone 1?
Yep.
Okay.
Good. Now that's hanging out, so there is no active call right now. Right?
Right.
Okay. Let's talk about how this works. You ready?
Okay.
We have 110 volts coming in to the terminals marked 120 VAC or voltage AC input. Right there. If we have power here, that green light should be on. Should be is the key word. Do you agree? If there's power, incoming power to 110 volt AC input, that light should be on. Do you agree?
Yeah.
Okay. Is that your final answer?
You said the
Be careful, that's live voltage,
going
by the
to
way.
H?
No, let's pay very, very close attention. If there's a line voltage going to terminals for the input of voltage AC, that green light should be on, correct?
For both terminals, yes. Hot and neutral.
Yeah, but, okay, yeah. If we have line voltage coming in here, that green light is gonna be on.
Correct.
Okay. Should be on is the key word, okay? Because there is a 24-volt circuit powering this control board. What I just did is remove the transformer from the equation or from this control. Now this transformer, which is sitting right here, is gone out of the equation. That green light is out, right? So when testing these switching relays, never assume anything. You always want to make sure you have power. I want you to get your voltmeter right now, and I want you to check to see if you have power between H and N, or hot and neutral. What do you got?
Oh, nothing.
Okay, what happened?
But there's no power going to the board because you disconnected the wires to the transformer?
Wrong answer. A good technician is observant of his surroundings.
Oh, I didn't realize you switched the power off.
I just switched power behind your back, correct?
Yeah, I didn't see it.
Yeah. Just like the housekeeper or the nanny could accidentally turn off the service switch, or should I say the emergency switch on top of the basement stairs, which now, you know, a day later or the next night or the next morning, they have no heat or hot water. And you get to the service call, and as you're walking down the stairs, a good technician is observant of their surroundings. You notice that switch in the off position, right? Do your troubleshooting steps. Don't just turn on that switch because you think it's off. You're going to go to the system. You're going to see that, hey, I have no power. You're going to verify there's no power, which you just did. There's no power. If I turn this back on, now check. Now you have 120 volts.
Yeah.
So now you have power. So let's say you went to a service call, you go to the boiler, you start getting at your tools, you check for voltage either at the boiler or at the control, you have no voltage there, and then you remembered, the switch on top of the stairs is off. You're going to make sure that, you know, sometimes these electricians or whoever, these handymen, they put them in the upside down. It could be on, it could be off, but that says off right there. That says on. Always troubleshoot. Don't just randomly, what I'm trying to stress here is don't just turn switches on without actually troubleshooting and testing first, right? Because now if you, for example, the switch is on the top of the stairs and you have no voltage here, you can go as far as your experience brings you, but never past the junction box, like for example, that junction box, which brings in voltage to the mechanical equipment, whether it's the boiler, the furnace, the relay, what have you. That's where our liability stops, right? We can't troubleshoot past that. So if you check the circuit breaker panel, doesn't appear to be tripped, everything appears to be on, and there's no voltage to the equipment, unless you have a electrical license behind you, your responsibility stops there. Now you need to refer the end user, the client, to a licensed electrician. Okay? So we have power here. Now, if I plug in that transformer, okay?
Okay.
I should have 24 volts here. Let's check for 24 volts. You got 29 volts. You got voltage there, right? So you know the transformer is good. Okay. So let's plug in our transformer. And look, our light has reappeared.
Right.
Okay. Now, let's turn on our zone. Our click is the circulator relay energizing zone 2. Let's get our voltmeter. Let's measure voltage between N and H on zone 2. You have 120 volts.
Yes.
Good. So we know that our circulator is getting power. Whether or not it's doing anything with that voltage, that's a whole nother conversation for another video. We're not focusing on that right now. But we're checking electrically to make sure this is doing what it's supposed to do.
Okay, got it.
Now, we have this extra wire. We're now going to wire this switching relay to this boiler. Okay? And similar principle, 2 wires. We have a red wire and we have a white wire. Okay? And these 2 wires are going to connect to the boiler by means of XX and TT. XX being the isolated end switch on our switching relay, okay, which is a dry contact. And what that means is, right now, get your voltmeter out, set it for continuity. Let's check for continuity between XX. No continuity, right? So if we were to turn on a zone, we should have continuity between XX. Correct?
I don't know.
Yeah, we should.
Okay.
Because XX is the isolated end switch, the dry contact, which will close and act as a thermostat, which acts as R and W going to TT on the boiler. So I want you to take the red and the white wires and carefully hook that up to XX. I'm going to turn the power off so we're safe. Remember about that nick in the insulation of the wire.
Okay.
And then get rid of the little tampon string, which looks really annoying. There you go. Okay. So now the red wire and the white wire is now hooked up to XX. So now this wire is going to the boiler. So if you come over here, you're going to have, look, I made it nice and neat and clean.
Okay.
Right? Big difference to what I did before, what you see over there.
Yeah.
And there's a reason for that. I only need 2 wires, but I'm leaving an extra one. And I wrapped the extra one, which could be common, right? And only because common is there. And if the customer decides to upgrade his thermostat to a Wi-Fi thermostat, guess what? The next guy already has the wire accessible to him. I'm not wiring it in, and I'm not cutting it short, but I'm leaving it there. So, see this? Next time you do something like this, remember that, and you'll be inclined to do that.
Oh,
Okay? Right. Now, we have 2 wires, R or red and white. Red and white, look at that, even tells you where it goes. We have thermostat right here. R, W, and C.
Okay.
If we had a Wi-Fi thermostat, we're going to use that common wire, or that blue wire, and wire all 3 wires. But we're just going to wire R and W.
Right.
Now, on other boilers, that's represented as TT, or 2 thermostat. Okay? So the red wire goes on R, the white wire goes on W. All right, we have the R and the W terminals wired, and they're noted as heat thermostat. On your boiler, it could be 2 thermostat, it could be TT, what have you, but that's that. Now, let's reconnect our wire, and let's turn on power. And let's turn on gas as well. That bad boy is going to fire up and do a little countdown sequence there. This is the US Boiler Burnham Alta. It is a tankless combi. This is a pleasure to work in. You can even get to the braze plate heat exchanger by getting your hand in it. I can't say the same for the other machines I have here, except the Alpine, but that's not a combi. But this is impressive, ladies and gentlemen. We're doing a little countdown on this machine. We're going to let it finish its startup sequence, and then we are going to fire up. All right, so let's go back to our relay. We have XX wired to TT on the boiler, correct?
Yes.
Okay, let's turn on power. We have our power light illuminated on our control. Our boiler is also on. Our thermostat is off. Let's turn our heat on. Let's raise our temperature above the ambient temperature. That is going to be, let's make it 70. We heard the click of the relay. That's zone 2 is energized. Now let's check for continuity between XX. We have continuity, right?
Yes.
Okay, turn the thermostat off while you're testing. No longer continuity.
No.
We heard the ticking of the multimeter because it's connected to something on the boiler. It's connected to 24 volts. Measure here XX, voltage. We have voltage there. Why do we have voltage there? We have voltage there because we're connected to R and W, or TT, on our boiler. There's power there. And that's another reason why you have a jumper between RH and RC on thermostats. And sometimes you have to remove that jumper when you have a 2 transformer system. That jumper is in place with a 1 transformer system when you're using heating and cooling on the same thermostat. If you have a separate air conditioning transformer and a second heating transformer, you can't keep that jumper there because you'll blow out something, either both transformers, 1 transformer, or the other. So to test that, remove XX. Remove one of the wires, or both wires. Okay, so these wires are eliminated. If you want, you can check for voltage there again. All right, you got 27 volts there. Now check for continuity between XX. No continuity. Hold on. Check for continuity. Continuity. Now you have no continuity. Right? Okay. So, we just wired the SR504 4-zone switching relay to the boiler. We wired XX and TT and proved that it works. Now we're going to duplicate a failure. All right, so our switching relay is installed. You now are at a service call for no heat out of your newly installed boiler, which is this Burnham Alta by US Boiler. Okay? No heat. They have hot water, but they don't have heat. You just pulled up to the service call. I want you to troubleshoot. If you don't know something, take no more than 5 seconds before you say you don't know something for time purposes, okay?
Okay.
Go.
I'll make sure the power's on and test the power's going to this board.
Okay.
Okay.
Good. Test away. Power's on. You have a green light on the power. You have 120 volts there. Okay. Now you have a call for heat. Okay, the red light is on zone 2. All right? That means the thermostat is closing the circuit, and R and W for zone 2 is energized.
Right.
Okay? So you should have 110 volts on zone 2. Let's test for zone 2, 110 volts. And you have nothing there. So now I want you to check between the hotline and ground. That's not, okay. On 120 volts there, that's a given. But on for that circulator zone. You already have 110 volts there, you check there, but right. Zone 2, hot and line. Hot and ground, sorry. You have no voltage there. Okay. So, let's say you did have voltage there. What are you going to check next? You have voltage to our circulator, right. Hypothetically. But the boiler's not turning on. because it's right next to you. You don't see it on. It's running. It's 122 degrees. Customer says they have domestic hot water, but they don't have space heating.
The connection from the switching relay to the boiler.
Okay, so what you're gonna do is you're gonna take a jumper and you're gonna jump out XX. There's a jumper, jump out XX. Okay, what do we have at the boiler?
Nothing.
Nothing.
Move around these wires a lot, so maybe it's broken inside.
Okay, so now our XX to, it's fine. Our XX to the boiler, I wouldn't do it that way. I would do it the way you had it, because you're gonna have dangling one end and and there's 24 volts there. Right? Because if you have both connected, this could not, if this hits something like metal, you could fry the transformer. So now you have XX jumped out going to our boiler, right? Which is R and W there, right?
Just confirm.
Remove the two wires now. Let's test for continuity on these two wires. Ooh. Transformer just popped. Okay, and now check for 24 volts on R and W. No, we don't have 24 volts on R and W. Now go to R and C. R and C. R and C. No voltage there. So we got a problem with the boiler as well. So now, if we just compounded the problem even more, we have a dead switching relay. We have a dead terminal on our boiler, and it's a brand new install. This stresses the need for surge protection. And at Pipe Doctor Home Services, we use the ICM 518. This is a split phase surge protection device. It's rated for outdoor use. This is perfect to protect very sensitive electronic equipment like high efficiency condensing boilers. There'll be a link in the description box down below. So now we're going to be troubleshooting two problems. The dead boiler, which is not giving us voltage between R and W, so we can interpret a heating call, and a dead Taco SR504 switching relay. All right. So there is our control, R, W, and C. And there's our transformer. We have onboard fuses, which is likely going to be for our boiler pump, system pump, and auxiliary pump. All right, we took a close look at all the fuses now. I took the one from the right and put it to the one on the left. There is the fuse. We tested continuity on it. There is no continuity on it. If you'll take a close look at it, it is burnt out. Now this fuse, or this fuse holder, that one, all right, is power going to our low voltage connections, printed circuit terminal block there. For testing purposes, I took that fuse holder from there, I put it there. Now we have voltage between R and W. We're going to put this back on there. We pulled this to inspect it. Everything's fine. We're going to turn our power back on. And now we're gonna show you guys on camera, 24 volts on R and W. Perfect, and we have our voltage there. Now, based on what we saw, it is likely that the SR504 switching relay had a problem, an electrical something went wrong with it. It's a brand new install. We're gonna check for any visible shorts on any of the low voltage, any of the line voltage control wiring. If none are present, we're gonna swap out the control with a new one, and hopefully the problem is solved and it was just a manufacturing defect. Maybe something went wrong, but let's pull this circuit board, take a look on the opposite side, see if we see any damage, what have you. It's a brand new install, so it could be a defect from the get-go, and it kind of sucks because it's only a day old, but as we complete and as we complete our commissioning process of an installation, we always tell the homeowner that even though it's been tested and commissioned while we're here, don't expect it, but if there's going to be a problem, it's going to be within the first week of an install. Why? Because anything man-made is subject to failure at any given point. If there's going to be a problem, it's going to be in the first couple days or a couple hours of use. So any manufacturer defect in the quality material that we installed should be known within the first couple hours or couple days or that first week of use. In this installation, there's not even a day later, hypothetically, something wrong with the control board, killed the fuse going to there. Now, if there were more problems with this, or if we saw a problem with this, obviously something wrong with the control. It's a lot more than a fuse, but nonetheless, we're going to replace that switching relay with a new one. So, step by step, let's get it done. So conveniently, this is an SR504 4-zone switching relay. This is an SR502 2-zone switching relay. We only need 2 zones. I only got 2 zone in my truck. We're gonna put in the 2 zone, taking out the 4. And hopefully the problem goes away and we don't have any other callbacks here. So the first thing we're gonna do, we're gonna take our multimeter, we're gonna make sure we don't have voltage at N and H, neutral and hot, of our 110 volt input. Okay, we have no voltage there, so it's now safe to proceed to remove all of the wiring, line voltage and low voltage from this control. All right, now the wires are going back, wire for wire, zone 1, zone 2, and then our 2 thermostats. All right, not the neatest looking of replacement relays, but nonetheless, everything is in there. Let's turn the power on. We have 2 zones actively calling right now. Yep, that works as well. Turn that back on. Good. Let's turn our boiler back on. Let that do a startup sequence. And then we'll make sure we're good to go. Didn't even notice that there. Burnt out component on the printed circuit board here. Yeah. Taco, what's up with that, Taco? All good, but at least now it works.